Hi, this video is on normal distribution and standard deviation. So when we construct histogram for some real-life data, we often gonna run into a situation that the majority of the data items is gonna fall right at or near the mean. And as we start moving away from it, the numbers are beginning to diminish. So the histograms are gonna start getting lower, those bars. So for example, if we look at the weights of 11-year-old boys in pounds, so what we see here is that the majority of them fall around that 70-80 range. And as we start going towards higher weights or lower weights, it's going to begin to diminish. And if you do it for the entire population of 11-year-old boys, you're going to get a very nice and smooth curve, and it's going to look like this. So this is an example of what we call normal distribution. It is also known as Gaussian distribution or bell curve. And this graph is going to be symmetric about this line that passes right here, which is where the mean is going to be. And in this case, the mean, the median, and the mode are going to coincide. So what do we need to know? There is one rule that we use as a good estimation tool. It's called 68, 95, 99.7 rule. And what it says to us is that when you deal with data like that, about 68% of data is going to fall within one standard deviation of the mean. So this is one standard deviation below, this is one standard deviation above. About 95% of data is going to fall within two standard deviations of the mean. So that's 2 below, 2 above. And 99.7% of data is going to fall within 3 standard deviations of the mean. These are just the symbols. This symbol represents the standard deviation. This is sigma, and this is mu, which often represents the mean. Okay, so let's go ahead and take a look at some problems. Here's a question. Newborns have a mean weight of 3,500 grams and standard deviation of 550. The weights of newborns are normally distributed. What percentage of newborns have weights between 2,950 and 4,500? Well, first thing you need to do is understand how these numbers are related to the mean. So this number here is minus 1 standard deviation. It's 1 standard deviation below the mean. And this number here is 1 standard deviation above the mean. And as I already explained just a minute ago, if you have values that are within 1 standard deviation away from the mean, then it's going to contain 68% of the data. So the answer here is going to be 68%. Let me go back to this graph for a moment. Basically, we say this is 3,500. This is, I'm sorry, 3,500. This is 2,950, and this is 4,050. 68%. What percentage of newborn have weights between 2,400 and 4,600? So 2,400 is going to be minus 2 standard deviations, and 4,600 is going to be plus 2 standard deviations. You can do the math to verify it. So what percentage falls within 2 standard deviations of the mean? That is going to be 95%. So the answer here is 95%. Example 2, a particular light bulb has a mean life of 1,800 hours and the standard deviation is 440. Light bulbs' lives are normally distributed. The question is, what percentage of light bulbs will fall between 920 and 2680? These two numbers, 920 is going to be minus 2 standard deviations and 2680 is going to be plus 2 standard deviations. So within 2 standard deviations, you're going to have 95% of your data items. So here, just to connect it to that, this is what we're talking about. One value is right there, the other value is right there. Between them, it's going to be 95% of the data. What percentage of light bulbs will last between 480 and 3120 hours? So that's going to be, this number here is going to be minus 3 standard deviations. This number here is going to be plus 3 standard deviations. And that is going to contain 99.7%. Okay? So that's that. Now let's take a deeper look into this. So if you take this, we said 68% is contained here, right, within 1 standard deviation away from the mean. Well, since the graph is symmetric, then it's going to break evenly into 34%. Minus 2 standard deviations plus 2 standard deviations. In here, it's going to contain 95%. So that means that half of that contains 47.5. So we got 34 here, 34 here, that's going to contain 13.5, that's going to contain 13.5. So when you go to 3 standard deviations away from the mean, it's 99.7. And you're going to end up having here in this portion 2.35% and 2.35%. Okay. So what we're going to do, we're going to take a look at a problem that involves practicing this, because often, like the problems that I just showed you, they're exactly plus 1 standard deviation minus 1 standard deviation, or plus 2 minus 2. But what happens if it's not symmetric? So let's go ahead and take a look at this problem. Australian koala bears have a mean height of 21 inches and a standard deviation of 5. Heights of koala bears are normally distributed. So what percentage of koala bears have weights between 21 and 26 inches? Here's what I'm going to do for this problem, just to make it easy, because we have quite a few questions here. I'm going to go to the previous graph and put all the numbers there. So let me go back to this graph and put my numbers here. So this number here is going to be 21. This is the mean. 1 standard deviation above the mean will be 26. 2 standard deviations above the mean will be 31. And 3 standard deviations above the mean will be 36. 1 standard deviation below the mean will be 16. 2 standard deviations below the mean will be 11. And 3 standard deviations below the mean will be 6. So what we're going to do here is we're going to use that to help us with answering these questions. Okay? So between 21 and 26. Let's do that first. 21 and 26. See this here? Your answer is going to be 34, half of 68. So 34%. Between 11 and 21. 11 and 21. That's between the mean and minus 2 standard deviations below the mean. So it's 13.5 plus 34. These two together, right? This is 11, this is 21. So that will give us 47.5. Okay. Between 16 and 36. Let's see where those numbers are. 16 is right here, 36 right here. So what we're going to do is basically add all these numbers together. 34 plus 34 plus 13.5 plus 2.35. All right. So if you add all these together, let me go ahead and do it. It's going to be 34 plus 34 plus 13.5 plus 2.35. And that's going to give us 83.85. So this will account for 83.85. By the way, I just wanted to mention that I'll go into the next problem. It's actually a helpful thing. Hold on, let me start this problem. I'll go back to the chart. For 11 to 26. So here's 11 and here's 26. So we're going to add this, this, and this together. Right? So it's going to be 13.5 plus 34 plus 34. That's going to give us 81.5. Percentage of koala bears have heights above 31. Well, let's take a look. 31 is here. Above is going to be these two numbers added together. It's going to give us 2.5%. Alright. And what percentage of koala bears have heights below 16 inches? Below 16 inches. That's right here. So we want this part, right? So 0.15 plus 2.35 plus 13.5. And that's going to give us 16%. What I wanted to tell you just a minute ago is these things are very visual, and you can actually find templates like this on online. You can Google it, just type it in, you can see a chart like that, and when you are going to do problems like that, it might be very, very helpful, at least in the beginning, to put all these numbers here, just like I did. And then you know, when you try to figure out, it's going to be a lot easier to see where each number is and what parts you need to add. Okay, and that's all I had. I hope this was helpful.